The last part of 2.4 is talking about continuous compound interest. And we're going to do an activity in class to explain where this formula comes from, but for now, I'm just going to give it to you. And everything means the same as it did before, right? This is still account balance. This is still principal. This is still my interest rate as a decimal. And this is still my time in years. But this E is new, and it's a number. It's not a variable. And this is sometimes called the natural constant, or it's sometimes called Euler's number after the mathematician that discovered it. And it's just like pi, it's an irrational, non-terminating number. It's approximately equal to 2.718. And again, we'll talk more about like how it all works later. But for now, let's just work with the formula. So if we've got this 4-year CD earning 2.5% interest compounded continuously, there's kind of my keyword. If that account is opened with $750, let's find the balance when the CD matures. And again, compounded continuously. The only time you're going to use this formula is if you see the word continuously in the problem, right? So when I see the word continuously, that's when I'm actually going to use this. So let's isolate what we know. We know that we have a 4-year CD earning 2.5% interest. And we're opening the account with $750. So we have a 4-year CD earning 2.5% interest. Opened with $750. What is the balance? Well, let's find out. Plug in what you know, solve for what you don't. And again, it's really important to obey your order of operations here. Did I mess that up? I did. This should be 0.1. Order of operations, right? Exponents comes first, so I'm actually going to simplify this piece first. I prefer just to enter it all into my calculator in one go, and that way there's no question about order of operations. The calculator will just do it for me. But if you're in a position where maybe you don't have your graphing calculator, just keep your order of operations in mind. But again, I like to just enter everything just in one go, and there's no question about what order of operations is. It just does it, and it gives me the answer, and there it is, done. And that's really all I'm going to ask you to do. I'm not going to ask you to do an APY problem with this. It's just plug it in and give me what the answer is. There is one extra step I do want to talk about, and that's because every function or every operation has an inverse. Right? Squaring something has taken the square root. Addition has subtraction. Well, what we'd call exponentiation, right? Taking this e and raising it to a variable x, has an inverse, has an undo. And its undo is what we call the natural log, and we abbreviate with this ln of x. And it has this property, no different than, like I said, no different than the square root of x squared all cancels out, or the square root of x squared all cancels out. So too does e to the ln x all cancel out. And more importantly for us, ln of e to the x all cancels out. We like this one a lot for these problems. Because what this step allows me to do is actually get up into the RT part of this function. It actually lets me get up into this bit here, so I can actually solve for either rate or time, like we're about to do. So Max wants to earn $1,200 in an account that he opened with $1,000. He plans to reach his goal in 5 years. Find the interest rate. Compounded continuously. So there's my buzzword. Let's isolate what we know and solve for what we don't. Well, I want to earn $1,200. I want to have $1,200 in this account. I guess this is really a poorly worded question because if I'm going to say I want to earn 1,200, well, does that mean my account balance is 2,200? When I wrote it, I meant it to be balance equal to 1,200, so we will stick with it and I will remove the ambiguity in my tests. We open that account with $1,000. He plans to reach his goal in 5 years. What interest rate must he earn? So that's what we're solving for. Let's plug in. 5R. Again, order of operations. I cannot combine those. Cannot multiply the 1,000 and the E. There's like invisible parentheses here or something. So my first step is to really divide like this. And now, well, I want to solve for that R that's up there. And I can't just divide by E because that wouldn't remove the situation. I need to employ my new little trick here, my ln. And I'm going to do that by just taking the ln on both sides. So what does that do? Well, that gets rid of this on that side, and it leaves me with the 5R. And ln2 is actually a number. Oh, sorry, ln 1.2 is a number. There's a button on my calculator for it. It's about 0.182. Call it 0.1823. So my last step is just to divide, and I get approximately 0.0365, which we want as a percent because it's a rate, and I should express my rate's final answers as percents. So I know that this can often be tricky for students when they're learning logs for the first time, and if you haven't seen this before, it is a little bit strange, but we want to think about it just like another trick in our tool belt of equation solving, just like I said, just like having squares and square roots, plus and minus, e and ln. And it removes, they kind of cancel each other out, leaves me with the exponent, so that way I can actually solve the problem for things that are up in the exponents like that. All right, so kind of working on this new step and getting used to it.